Okay, so in our last video, we looked at converting from standard to vertex form by not completing the square. I know we said we were going to get to solving using the quadratic formula, but that's actually going to be for next week. Okay, so we're not going to get to that in this video either. What we're going to focus on today is a method called completing the square. So let's remind ourselves of what we worked on. Those of you that turned in your classwork, I returned feedback with the solution, so this should be a review. Right, y is equal to x squared minus 6x plus 4 in vertex form. Okay, so I know this is standard form. X squared plus bx plus c. No numbers written before the square term, so I know it to be 1. B is negative 6. C is positive 4. Okay, so the x coordinate, my vertex, the opposite of b divided by 2 times a. 6 divided by 2 gives me 3. The y coordinate of my vertex, I take that value that I just found and I plug it in wherever I see x. Okay. Oh yeah. Oops. Sorry, guys. So whatever I get for x, I replace into my function, and I get 9 minus 18 plus 4, negative 9 plus 4, so that gives me a y value of negative 5. So into my vertex form, a x minus h quantity squared plus k. So now we replace all our important pieces. Okay, a, h, and k. So y equals, you can write the 1 or you don't have to, x minus the x coordinate of the vertex. Because the y coordinate of the vertex is negative, I write it as a minus sign. Okay, I'm not going to lie. I prefer this method. It's easy. Negative b over 2a is so important. It gives us a lot of information about the graph of a quadratic. But completing the square is a very useful method, and we use it in calculus. So we introduce it now, you study it again in Algebra 2, and we use it in pre-calc and calculus. Okay, so the ultimate goal is writing in vertex form. Okay, now notice I chose the exact same function as the original, okay, as number 1. So we already know that the value of a is 1, and we found the vertex to be 3, negative 5. So it better work out to be the same. All right, so when we complete the square, what we're doing is we're creating this part of the vertex form. Okay, so I complete the square on my x's. So I'm going to keep my x's together. I'm going to leave a little space, and then there's my plus 4. So I just separated the x from the constant term. All right, so completing the square. What happened to this? Okay, so let me remind you, here's a, here's b, here's c. So to complete the square, I take half of my value of b, and then I square it. Okay, so I take half of my value of b. That gives me negative 3 squared. Negative 3 squared is positive 9. The value that I add will always be positive, because when I square any number, it becomes positive. So that's going to be a plus 9. Okay, well, this is an equation. So I just added 9 to this expression. I have to balance that out by then subtracting 9 as well. So if you think about it, 9 minus 9 would go to 0. They would cancel each other out. But I'm just rearranging the equation to get it into this form. Okay, what comes next? So now these guys get combined, and there's my minus 5. All right, so remember from the previous slide, we already know what the answer should be. So I already have my minus 5. How do I get it to be squared? Well, what you're doing is you're really factoring this thing, but it always factors into some quantity being squared. What's that quantity? That quantity will be x minus 3. Let's think about where those things came from. My x, that's my square root of x squared. Where did you see minus 3 already? Well, my minus 3 is exactly the value of b over a. Excuse me, of b over 2. Okay, so now when I sort of clean it up and put it all back together, I have y equals x minus 3 quantity squared minus 5. Exactly what we showed on the previous slide. Okay, so let's go back through this, okay? There's your standard form. When a is equal to 1, we complete the square. Let me write that as a 1. So a is equal to 1, so I don't really need it there. I complete the square by taking x plus b over 2 quantity squared. And then this c, remember that I have to then take whatever my value is and subtract that b over 2 quantity squared. This will give me the value of k. This will give me my value of h. So let's look at another example. Complete the square to write this in vertex form. I'm actually going to move number 4 to be number 3. Okay, so a equals 1, b equals negative 12, c equals negative 9. But I want you to practice completing the square. So first thing I do, I keep my x's together. I put my minus 9 separately. Okay, I need to add some number and then subtract its value. What number do I add to complete the square? I take half of b and then square it. Half of negative 12 is negative 6. When I square that, I'm actually adding 36 to my expression. To maintain balance, I then have to subtract 36. Okay, so now I gotta clean it up. So it needs to be in the form y is equal to something squared, and then I need a number on the outside. So this number here, negative 9 minus 36, gives me a negative 45. And now what goes in here? X minus 6. How was I able to do that so quickly? Because the minus 6, I always use whatever that value of half of b would give me. So, something I failed to ask you, I keep doing that. Okay, so now from here, you better be able to tell me what the vertex is. So now if it's in my vertex form, I take the opposite of the number inside the parentheses. So the opposite of the minus 6 would be positive 6. And now my y coordinate for my vertex is negative 45. Okay, let's try another one. I'm going to go back to this and I'll make this number 4. Complete the square to write this in standard form into vertex form. So I keep my x's together and I put my value of c over there. I know that I'm going to have to add some number here, and then I'm going to subtract the exact same number. Remember, I always know I'm adding because the whole rule is to take half of that number and square it. So whenever I square a value, I know that it becomes positive. Okay, when I square a fraction, negative 3 squared is 9, 2 squared is 4. So 9/4 is what I'm actually adding to my expression. Okay, so that means I have to subtract 9/4. All right, I automatically know the general form, something squared. All right, now let's check out how our calculator is going to help us. Okay, so all right, so I had to combine 5 minus 9/4. All right, so when I look at this on a calculator, there's a couple things that I want you to do to clean this up. Whenever you deal with fractions, I want you to get in the habit of putting the fractions in a set of parentheses. That's the first thing. So when I take 5 minus 9/4, I get 2.75. I'd really like you to write that answer as a fraction because my x-coordinate will be written as a fraction. So if you're working with a graphing calculator, you're going to hit your math button. And notice the first option, arrow to a fraction. I'm going to hit enter. So what that means is it's going to take my answer from the previous line and it's going to write it as a fraction. So 11/4 is the value that I get when I combine this 5 minus 9/4. Okay, so plus 11/4. Now what goes in here? This is very simple. X minus 3/2. Where did my -3/2 come from? My -3/2, I had already determined that when I took half of the value of b. So now from here, I automatically have my vertex. So the coordinates of my vertex are +3/2, comma 11/4. All right, so I really want you to work on combining these with a calculator. But let's talk about, all right, I don't have a calculator or I don't have a graphing calculator. So what do? I have to multiply that 5 by 4/4 because that's my common denominator. 4 times 5 is 20. My 9, I don't need to multiply that by anything. It already has the common denominator. And I verify yet again that I get 11/4 as my y coordinate. Okay, we have time for one more example, and I'll give you practice problems in the assignment. Write this in standard form. Okay, so now notice this is in vertex form, very useful for graphing, and I want to get it into standard form. So ax squared plus bx plus c. So I hope that we can all agree from here our value of a is 2. I should make that a plus k. I also know that my vertex is the point 3, 1. But I can't determine my vertex from standard form. So what do we have to do to this expression? We have to expand it. 2 times x minus 3 squared plus 1. All right, I'm going to focus on this guy first. So remember, when we square something, we multiply it by itself. So I have to make sure that I'm taking x minus 3 and I'm multiplying it by x minus 3. So I got to distribute the x to both terms. And then I have to distribute the -3 to both terms. Be careful. -3 times -3 is +9. Now I combine my outer and my inner. Hopefully this doesn't seem foreign to you. We've been doing this as we've been practicing factoring. So x minus 3 squared gives me x squared minus 6x plus 9. So now notice the other stuff around it stays the same. I've only done my little bit of side work there. All right, pause the video. I want you to try the next step. All right, so my next step would be to distribute the 2 to all 3 terms in the parentheses. 2x squared minus 12x plus 18. Don't forget about my poor little plus 1 here. Okay, now my final step, pause the video and try and determine what the final step would be. So my final step would be, now my like terms are 18 plus 1, which gives me a value of plus 19. Okay, so we've looked at standard to vertex. Now vertex to standard I think is easier, but it's dependent on you doing your side work and you're distributing properly. Okay, we'll finish there for today.